So now that we know how to graph sine and cosine, we're going to move on to graphing cosecant and secant because the setup is nearly identical until the very last step. Okay, so let's look at their graphs. We're going to start with cosecant. Okay, if you remember, cosecant is 1 over sine. So when we are graphing cosecant, we have the same labeling as we had for the sine graph. Now, I like to graph the underlying sign, at least when I'm starting. So in a different color or using a lighter part of your pencil, here is sine of x graph. Now, to turn a sine of x graph into a cosecant of x graph, everywhere the graph crosses its center line, we're going to put an asymptote. And then we're going to put horseshoes on top and bottom of the graph that just touch at that top and bottom. And the black is the graph of cosecant. Okay. One thing to note, amplitude in cosecant and secant plays a different role. For sine, amplitude was the distance from the center to the top or from the center to the bottom. For cosecant, amplitude is half of this distance between the two horseshoes. So it tells you how far apart those horseshoes are. Let's look at secant of x. Once again, the graph has the same labelings as for sine and cosine. This time, I'm going to graph cosine underneath it, because secant is 1 over cosine. But then once I have the cosine graph, I'm going to turn it into secant the same way I turn sine into cosecant. I'm going to put asymptotes everywhere the graph crosses its center line, and I'm going to put horseshoes on top and bottom of the graph. The only thing you'll notice here is that the horseshoe on top was kind of cut in half. Part of it on the left, part of it on the right. Okay. So, let's graph an example of each. When I'm finding the x and y coordinates, I'm going to pretend I'm doing sine or cosine. In this case, I'm pretending I'm doing sine. So the center is at -2. From here, the high is at -2 plus 3 or 1. And the low is at -2 minus 3 or -5. To find the x coordinates, I'm going to take the thing inside the parentheses and set it equal to my original special points. And I'm going to solve each of them for x. So I get negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Okay. And now I'm going to start graphing it. So I have a center at -2, a high at 1, a low at -5. I have my x coordinates. Okay. Now, it's not actually necessary to draw the full sign underneath, but I do tend to like to do the points. The sign points underneath are going to be center, high, center, low, center. Now, to turn it into a cosecant, everywhere it was on the center, I'm going to put an asymptote. And I'm going to put horseshoes that touch the high point and the low point of what would have been the sine graph. Okay. Let's do an example of secant. The center is the 2, The high will be 2 plus 1/3, or 7/3. The low will be 2 minus 1/3, or 5/3. Okay. To find the x-coordinate, I'm going to take the thing inside the parentheses and set it equal to my original special points. And solve each one for x. So I get negative 9 pi over 8, negative 3 pi over 8, 3 pi over 8, 9 pi over 8, 15 pi over 8. Okay. So I have my 2, my 7/3, my 5/3. I'm going to have my 5 points. Okay. Now I'm going to pretend I'm drawing cosine, only I'm just going to do the points for it. Cosine starts high, then goes center, low, center, high. Now everywhere that crosses the center, I'm going to put an asymptote, and I'm going to put horseshoes on top and bottom. And there is my graph of secant. So, of the 4 trigonometric graphs we've done so far, the only difference really is the pattern that you draw at the very end. But the hard part, the finding the x and y coordinates, is identical no matter which of the 4 trigonometric graphs you are drawing.